Welcome back to Zenith Poker. In today's Foundation Series episode, we will be comparing equity to pot odds. So what do I mean by that? So if we recall our definitions for equity and pot odds. So recall the definition of equity. So the equity QI, the equity for player I, given the board B and the random variable vector X, which represents the hands of all the players, is simply the expected value of the showdown function for player I with the random variable Z, and in taking that particular random vector X for the hand ranges, where Z is the random variable uniform on RB, the runouts, all the possible runouts. This RB number here is the set of all possible runouts coming from B. Okay, so that's the equity. And now we want to also define the pot odds, right? So recall what we mean by pot odds. For a relative bet size S, the pot odds omega is equal to S over 1 plus 2S. Okay, so given that we've got our definitions of equity and pot odds, we're going to use a shortcut to figure out the correct action to take for an all-in bet. Okay, so we have this statement that for an all-in bet, or a river bet, and I should say or raise, right? So for an all-in bet or a river bet or raise, if the equity for player I is greater than the pot odds that they receive, then player I has a calling expectation greater than 0 or greater than folding. Okay, so this is for an all-in bet on any street or a river bet, simply comparing the equity to the pot odds. Okay, so let's go and have a look at an example of this. So in this example, we have the board B is equal to this Queen of Clubs, Jack of Hearts, 10 of Diamonds, 5 of Diamonds. Okay, we have the starting pot size. P is equal to 55. All right, so starting pot size is $55. The starting sack size, right, which we're going to consider for an all-in bet. So that's going to be the bet size. The bet size is 38, and it's all in. Okay, so this is important. We can see hero's hand, right? So hero's hand, let's go with H. Hero's hand is the Queen of Diamonds, 7 of Diamonds, and villain's hand, a distribution, right? So villain's distribution has a probability mass function, piece of V of X, as follows. So 0.7. So this distribution is 0.7 for ace of spades, king of spades, and 0.3 of king of diamonds, two of diamonds, and 0 otherwise. Okay, so we're asked to figure out whether or not hero should call this bet, okay, in this example here. So there's quite a few things going on and we need to figure this out. So let's work towards this, right? So the easiest thing that we can probably do to start is simply to calculate the relative bet size. So we use these two values here, the pot size and the bet size, to calculate the relative bet size. So let's start with that. So the relative bet size is going to be the bet size divided by the pot size. So here it's going to be 38 over 55. And this is approximately 0.6909. Okay. Now, from the bet size, we can calculate our pot odds. So omega, remember, is equal to S over 1 plus 2S. So here we plug in this 0.6909, right? Right, so it's approximately equal to, I should say, 1 plus 2 times 0.6909. So it's approximately equal to 0.2901. Okay, so we've got our relative bet size, and then we use that to calculate pot odds. All right, let's get some more space to do some work. The next step now is that we need to figure out what our equity actually is. And for that, we can look at the showdown function for all the possible river runouts. Okay, so let's figure out what our showdown function actually is. So the showdown function for hero, given that board B and hero's hand. So hero's hand, once again, was the queen of diamonds, 7 of diamonds, right? And we have villain's hand is a random variable. Let's call that B, right? This B, just to be more thorough with things, is the queen of clubs, jack of hearts, 10 of diamonds, and then the 5 of diamonds. Okay. So this V, we don't actually know what it is. It could be one of the two possible outcomes, all right, because it's a random variable at the moment. But what we can do is we can just define this as two possible outcomes. Okay. This showdown function, we can split it up into two different things. We can look at the showdown function B, comma, hero's hand H for when villain has the ace of spades, king of spades. And then we can also look separately when villain has the king of diamonds, 2 of diamonds. Okay. So looking at each of these, the first one where hero's queen of diamonds, 7 of diamonds is up against the ace of spades, king of spades. This is going to have a showdown function for hero. So let's write this out. Queen of diamonds, 7 of diamonds, ace of spades, king of spades on this board. Right, now we have the board, or basically all the possible runouts starting from B, right? I should be more specific with that. This is actually the runouts from B, okay? What I've actually got is the number 1. So hero wins when there's a diamond on a diamond river, right? So how many diamond rivers, or how many possible diamond rivers are there? There is, we need to draw to a flush. So there's 9 possible flush outs to win. So one of the 9 flush rivers and 0 otherwise, right? And the deck is 44 cards. So essentially we win 9 of the times and we lose 44 of the times. Now let's have a look at what happens when hero is up against the king of diamonds, 2 of diamonds. Okay, so the showdown function for hero for all the runouts, queen of diamonds, 7 of diamonds, up against the king of diamonds, 2 of diamonds. We win when this is going to be the otherwise actually. So we can just, it's easy to count all the possible outs for the king of diamonds, 2 of diamonds. Right. So here, the king of diamonds, 2 of diamonds, it will win on one of the 3 remaining kings. It'll win on one of the 7 remaining flush cards, or it will win on one of the 6 straight cards. There's an overlap between the flush completing cards and the straight completing cards. There's the ace of diamonds, which will complete both the straight and the flush, but we only really count the flush. And then there's also the 9 of diamonds, which does the same. We only count the flush. So there is 16 outs here, right? So there's 16 outs that we will look at. So we get a value of 1 on one of the 28 non-outs and a value of 0 on one of the 16 outs. Okay, and now I can put all of these into expectation to get the equity. So let's get the equity for hero, given the board and hero's hand, right, which we should write out in full, queen of diamonds, 7 of diamonds, and then villain's hand, V, which is a random variable. Okay, V is not a random variable, we know what that is. V is a random variable, but the showdown function uses the deck and creates a random variable from the deck. So this is the expectation of the showdown function for our random variable Z, right, which is the uniform random variable on top of RB, to be specific, of queen of diamonds, 7 of diamonds, and villain's hand, right, V. Okay. So expected value. This is equal to the double sum of Z in RB, right, or lowercase z in RB, and X in the set of all hands of the showdown function for hero, with Z as a placeholder, queen of diamonds, 7 of diamonds, which is hero's hand, and X, which is villain's hand, times the probability distribution for villain's hand distribution. So it's PV of X. And then we multiply that by the probability distribution for the deck, P of Z. Thankfully, we know that, let's have some more space over here. Thankfully, we know that P of Z is in fact uniform. So that's uniform random over 44 different cards. Okay. So this is just the 1 over 44. RB is all the runouts, right? And we know what all possible runouts are going to be. And then we've got this is defined at the start of our question. We know what the ranges are from here, right? We know this information. So we just plug all that in. Okay, we just plug all that in. And then we see that for the situation where villain has the ace of spades, king of spades, right? In this particular situation, let's use a different color. In this particular situation, that happens 0.7% of the time. Sorry, 0.7 of the time, so 70% of the time. And hero will win on 9 out of the 44 different river cards. And when they've got the king of diamonds, 2 of diamonds, hero is actually going to win 28 out of the 44 different river cards. But that, because of their range, how that's distributed, only occurs 30% of the time, 0.3. So we put all these together and we calculate it, and we get a number approximately equal to 0.3341. Okay. So our equity for hero is approximately equal to 0.3341. Now, we go back and we have to compare our pot odds, which we calculated here, to our equity, right? So looking at it, we've got an equity of 0.3341 and then a pot odds of 0.2901. So that means that the equity for hero is greater than the pot odds for the bet. Therefore, hero should call. Right? Because their expectation for calling is higher than the expectation for folding. So here is a plus EV decision, right? The decision that makes the most money on average will be to call. All right, so that example is an example of how we can use equity and pot odds to simplify some of our decisions. We first went over and redefined or recalled what we meant when we said equity and what we meant when we said pot odds. And this particular statement, we'll prove this later when we look more at expected value. We'll prove this statement a bit, but for now, you can basically say that if we're facing an all-in bet or raise on a non-river street, or we're facing a river bet or raise, if the equity is more than the pot odds, then that player should at least call. Right, there is still the option of raising all in certain situations. For example, in these river bets that aren't all in, there is the third option of raising all in. But basically, it's saying that we have the option to call instead of folding. All right, so thanks for watching this video. Hopefully you learned something, and I will see you all in the next one. Bye now.